Welcome to the August WinHUGR meeting. I like kicking things off at 6:15 because when we have interesting speakers, I want to make sure they have lots of time to go through their entire presentation and hopefully answer any questions that everybody might have. So our agenda tonight is basically we kick off at 6:15. We've got a couple of quick announcements. We have a member conversation, 5-minute talk from Dimitri. And we have our main guest speaker, Brandon, and then we'll have some door prizes for everyone. There are refreshments and HoloLens demos available up front for those people who haven't had a lot of access to HoloLens as of yet. And 8 p.m. we kind of wrap up, but pizza and talking, usually we're out of here by 9. So that's the general agenda for the night. As far as the updates, since we last met, a number of things have continued to change. Unity HoloLens HTTP, the technical preview, is now up to 5.0 F3. So what that basically means is that the beta version of 5.4 has now gone live. Brandon may correct me on this, but I believe we're now synced to the release candidate 3 code that went out. But this is pretty much a HoloLens version of what's the 5.4's now should be. There's a matching emulator. So, sorry, the August flight is also out. And that's the anniversary update that Microsoft has done. So we had an update for the HoloLens in May, which you could reflash your device with a new version of the OS. Now in August, they've got the anniversary edition. And there is a matching emulator available as well for those folks that are working off the emulator or that want to emulate what they're doing on the device as well. There's also a commercial suite release that was announced as part of this release as well. It's still not 100% clear, at least not to me. I believe that the bits that are in the anniversary update can be enabled if you have the right device management server that you're connected to, but I'm not sure. I know that they are now starting to ship devices. So further down the list it says the waves are now over. We went through waves 1 through 5 or 1 through 6 when we all had applied to try and get our hands on a HoloLens, and we would have to wait for a wave to come up, and then we were able to buy 2. Now you can buy up to 5, and you don't have to do an application. And if you're buying at an enterprise level, I believe there might be an enterprise commercial SKU that matches with the commercial suite. But that's so fresh that it's still a little bit foggy and unclear. The HoloLens Toolkit has gone through continuous updates, but there was a specific set of new features that were tacked in, the build window and the gaze ruler, something you might want to check out if you haven't checked out the latest builds on GitHub for HoloLens Toolkit lately. And of course, there are continually more apps appearing in the store. We're now approximately, I think, 40 when you look up HoloLens store items, and growing all the time, but it's still a great time to get something in there. We're not talking tens of thousands that you have to fight against to get some shelf space. Visual Studio Update 3 came out last month, but there have been multiple patches that have been released since then. So if you have update 3 and you think you're all good, you might want to check because there are a few patches that are worth noting. And with that out of the way, I'm going to invite Dimitri up, and I'll call up his slide deck. He's going to share some specifics about HoloLens Toolkit and some of the member contribution or community contributions that he's been involved in.
Great, thanks, Dwayne. Thanks for the intro. Hi, everybody. So my name is Dimitri again, and I run a local startup called VR. We focus on using AR for enterprise. If you want to learn more a little bit about what we do for this company afterwards, So if you want to learn more a little bit about what we do with Context VR, please talk to me afterwards. And just a little plug. I'm looking for a couple of things I need to help with, like shader development. Anyway, while Dwayne is filling up my slides, I'm going to get started. So. Just a little bit about my background. I'm an engineer. I've had over 15 years of software engineering experience, and I've been in this focusing on Unity, AR, VR development for the past probably more than 3 years now.
Just get out.
Awesome.
Step away from the speaker.
Oh, yeah, yeah. Great. All right, so again, Dimitri here, and full stack development, Unity, AR, VR, MR, whatever you want to call it. Multiple startups, and I'm looking for a couple of experts to help to do some work on a few projects that I have. So how many of you are developers in the audience? Okay, so a lot of people, and how many of you are already familiar with Toolkit? Well, for those of you who are not familiar, who just want a refresher, Toolkit is a it's a open source project started by Microsoft HoloLens team. I did. Yeah. So it encapsulates and simplifies a few key concepts of working with HoloLens, things like gaze, gesture, voice, spatial audio, and spatial perception. They also call it spatial mapping. So today I want to talk about a couple of things, specifically gaze and voice recognition. So Toolkit provides a few components that simplify handling gaze and handling voice recognition when you're building a HoloLens app. So one of the things it provides, it provides a gaze manager that you can use to get information about objects that your gaze hits when you look within the scene. So the Unity SDK for HoloLens provides a keyword recognizer API, and Toolkit builds on top of that and provides a very simple way for you to add keyword recognition to your Unity HoloLens app by just dragging a prefab into the scene and just wiring up a few keywords and event handlers. So one of the problems, I was building an app, and one of the problems that I encountered for my specific use case is that Toolkit did not have a built-in ability to send keyword messages to objects instantiated at runtime. And as you already guess, most interesting Unity apps, most interesting apps in general, would have objects that were created at runtime. And so just to illustrate the problem for you, I did a screenshot of this. So as you can see, for you to be able to write no code and just wire up an event handler in Keyword Manager right here, the sphere object would need to exist in the editor, and so and then you can wire it up in the Keyword Manager. And so let me go back to this slide. So again, the problem is that the object would need to exist already in the scene hierarchy for you to wire it up in the Keyword Manager and write no code for you to handle that event. So sorry, not to handle, but to send that event. So I think a few HoloLens tutorials that I found, they talked about a couple of workarounds. You can handle on select event, send by gesture manager, and on gaze enter, on gaze leave events. For those of you familiar with the API, this would be the way to go. But I wanted to, now you kind of get into this territory. You need to have multiple keyword recognizers in your environment, and then I wanted to create a simpler solution that would allow people to avoid all of this boilerplate and would just handle this automatically, just like by dragging a prefab into a scene. So that's what I did. I created a couple of components and a couple of prefabs that are now part of the Holo Toolkit. So those changes are in the official Holo Toolkit. And so one of them is called the Focused Object Message Sender. It's a component that you put on the Keyword Manager object in the scene hierarchy. And what it does, it acts as a proxy object, so that when any of your objects are created at runtime, imagine 100 other objects are created over here at runtime. This proxy object would trigger, if there's a voice event that's triggered, it would be able to send that event to any object that you're currently gazing on. So just like a proxy object. And so a very simple solution, and I'll run the video real quick to illustrate how this works.
Recording.
So as you can see, all this grid of objects is just a grid of it's a random generated objects created at runtime. And so as I look at them, I can select them.
Make bigger.
And then send them events. And again,
Make
the
smaller.
key here is that these objects were
Make
created
bigger.
at runtime.
Make smaller. Make bigger. Make bigger. Make smaller.
So nothing too fancy. The overall change is probably less than 100 lines of code, and more than half of it is like comments and stuff like that. So, but you know, this process exposed me to how you contribute changes to the whole toolkit. And there's actually a second part of the solution that I'm not going to get into. It's very similar to the first part, but the key difference is that in this version, you can select objects for interaction by issuing an explicit voice command. I'm actually going to skip over the video in the interest of time. But the outcome is that now sending keyword events to objects that were dynamically instantiated at runtime is very easy. You don't need to write any code. You just drag and drop a new prefab from the Holo Toolkit, from your project view, right into the scene hierarchy, and you already have a couple of keyword events pre-wired for you, and you just change them to fit your application, but you don't need to write any additional code for sending those messages. And so what's next on my list is I want to add the ability to automatically register keywords. For example, you know, one of the things you see when you see holographic UI elements and you want to send events to those UI elements, I want to be able to both use the onSelect event when you use the airtime gesture. At the same time, I want to have the ability to issue voice commands to do the same thing. I think it's just an interesting idea to explore, so that you have this clarity between what you can do with your AirTag and what you can do with voice commands. And so, the idea is that I want to extract these keywords from UI elements like buttons and then use them in Keyword Manager to automatically register those voice commands based on the text on the button. So anyway, so to wrap this up, I want to encourage anybody to go onto the HoloLens developer forums. If you see an issue that you think there's a simple solution that kind of fits your use case, and that you think the community could benefit from, please feel free to fork the whole toolkit on GitHub. Experiment, make some changes, do a pull request, review the changes with the team. HoloLens team was very supportive throughout this process. I posted a link to the discussion. Check it out at the end of the presentation. I'll share that later after the talk. But please feel free to fork it, experiment, contribute back. The community will highly appreciate your efforts. And with that, if you have any questions, please feel free to reach out. But yeah, thank you so much.
So one of the really important takeaways from Dimitri's talk is that we as the community have a lot of influence over what goes into the Holo Toolkit and have the ability to actually contribute and modify the Holo Toolkit or contribute in ways that the Microsoft folks can decide if the modifications make sense for the toolkit at large. So as Dimitri mentioned, if you're a developer, then feel free to connect up and start submitting change requests. If you're not a developer, you can still be very active on the forums and get your voice heard and have the other developers that are on the forums pick up where you've suggested and go from there. So next item. We have one other member conversation insert. Carl at the back here has got an announcement about a hackathon that another group is up to.
Hi, my name is Carl. I'm one of the organizers of the Seattle VR Hackathon. Greg Howell's in the back there. I guess sort of flowery shirt is one of the other ones. This will be our fourth hackathon that we've done here in Seattle, and it's been a growing community ever since the first one in June. This will be September 16th through the 18th at the University of Washington Center for Architecture, Engineering, Research. Something ends in C or starts with C. But anyway, come find me after the presentation today. I'll give you details. If you're interested in what a hackathon is, I would imagine most of this audience is pretty familiar with the process, but it's very open, collaborative. Designers, developers, producers, ideators, everyone is welcome to this. Thanks.
So one other thing I could have squeezed in during the introductions, it kind of happened at last minute. You may have noticed we have a WinHUGR YouTube channel now, and we posted last month's video of our guest presenter on that channel. We're attempting, as an early experiment, to do live webcasting of our meetings. We've had a lot of international interest, and Christopher Rampey here at front is in the process of trying to broadcast this out to the world as we have our meetings so that people from all around the globe can enjoy and participate. This is the experimental one, but hopefully over time we'll make further announcements and get better publicity out there. So with no further ado, let's bring up Brandon. And Brandon is our first speaker that we've had direct from Unity. I was speaking a little offline with him beforehand, and I think one of the important points to take home here, Brandon's coming direct from the HoloLens engineering team, as opposed to some of the evangelists who've been off on the road that just evangelize Unity. He's actually been working with the VR and the HoloLens toolkits and inside guts of Unity. And he's one of the few people that can actually speak at Unity on the topic because their evangelists aren't up to speed yet. So we're really fortunate to get kind of an inside peek direct from the horse's mouth, so to speak. And please welcome Brandon. Woo!
Oh, no, that's fine. That's fine. I'm just going to kind of use the microphone off and on. Can everyone hear me okay? Perfect, perfect. Well, thank you for coming out tonight. So, as Dwayne said, my name is Brandon Fogerty. I'm a software engineer at Unity Technologies, and I work directly for the HoloLens team at Unity. This is really exciting technology, and really happy to be a part of it, and really happy to see what you guys do with it. So, out of curiosity, I'm just curious, can I get a show of hands of how many people have actually shipped a game or application of Unity? All right, right on, right on. Cool. So, the interesting thing about me is prior to working for Unity, I was actually a customer of Unity for about 5 years. So, I've had experience shipping games with Unity, and now have experience being in Unity and working from the inside. And one of the things that I just wanted to go ahead and say is that Unity really cares about this product, and we're very passionate about it, and we want to set you guys up for success. So if you guys ever have any problems or troubles or issues, please come find us in the forums. Unity, we have our own forums, and we have our own HoloLens threads, so please come find us there. We're there to help you out. Okay, so there are a lot of interesting things in Unity. Some of the things that I think are very powerful is the fact that Unity supports over 20 platforms. So you can write your game once, and you can run it on the iOS platform, so iPhone, iPad. You can also run on Android, Mac, Windows, Linux, Xbox, PlayStation. We support a lot of platforms. And obviously, you guys are here for the HoloLens platform. Something else that's really interesting is that we have a what you see is what you get editor. So tonight, I'm actually not going to go into too much deep detail into the HoloLens specifically, but that's okay because basically everything that you do in Unity is applicable to the HoloLens. And because we have a what you see is what you get editor, we have support for rapid iteration times. So basically, while you're running your game or your application, you can make changes in runtime, in real time, and see those changes reflected. The other thing that's interesting is that we have a very powerful asset pipeline. We have so many different asset types that we support. Model-wise, we support FBX models, we support OBJs. Something else that's interesting is that we support Maya scene files. So if you were to create a .ma scene file in Maya, we can import that too. We support Blender scene files as well, so you can just drag and drop that in. And the thing that's really amazing about that is that our APIs are very high level and abstracted. So when you're developing for Unity, you don't really need to know where your asset is coming from. It doesn't matter if it came from Blender or Maya. At the end of the day, you're going to have a mesh filter, and that's going to contain your vertices, your normals, your UVs, your tangents, etc. It doesn't matter where it came from. We work really hard to make sure that that process is simplified, and hopefully you guys won't have to worry about those low-level details. So when you start using Unity, you're going to quickly find out we have a lot of internal jargon. So I kind of want to go over some of this right now. So in Unity, we have a concept of scenes. Has anyone here used Flash before, by any chance? Okay, so if you've used Flash, scenes in Flash and scenes in Unity are very similar. You cannot have an application without a scene in Unity. You have to have a scene. That's your starting point. A scene contains a collection of game objects. So game objects are a fundamental object type in Unity. Every single object in your scene is a game object. And they all have their own unique transform. That means that each game object has a position and orientation that you can set. Now, game objects on their own are pretty boring. They don't really do much. So to make them interesting, we decorate them with components. Basically, you attach components to game objects. Components are just basically scripts that do interesting things. So in Unity, we have our own built-in scripts. So we have things like audio player, we have transforms, we have mesh filters, mesh renderers, etc. And those are the built-in scripts, but developers can also create their own unique components and decorate their game objects with those. So just kind of an example, when you're working for the HoloLens, to create a hologram, you need a game object that has at least these 3 components. You need a transform, so that you can position and set the orientation of your hologram. You need a mesh filter. Mesh filter, again, it's going to store your vertices, your tangents, your normals, UVs, colors, etc. And then you're going to have a mesh renderer component. Mesh renderer component is basically going to take the information from the mesh filter and it's going to render it. We have other components that work in a very similar way, like our mesh collider. The mesh collider would also require the mesh filter, and it would take that information in and create a volume from it so that you could interact with it, throw other objects at it, or collide, or you could use those colliders as triggers to trigger some other event. Again, we have another word we like to throw around a lot, assets. So again, we have 3D models. We support a whole slew of 3D model formats. Images are very similar. We support PNGs, JPEGs, TIFFs. You can actually import a raw PSD from Photoshop, and that will work just fine. We also support various audio formats, so the common ones, MP3, AAV. And then, curious, is anyone here familiar with Screen Tracker or Impulse Tracker formats? Okay, so those are also very interesting music formats. Basically, you record samples and then you can program your music. But yeah, we support those too. And as far as scripts, you have several programming languages you can write the code in. Most developers, I believe, use C#, but you also have the option of choosing JavaScript. And then we also have another programming language that is unique to Unity called Boot. Another word that we like to throw around a lot are prefabs. And the way I like to think of prefabs are basically templates for game objects. So let me describe a problem. Imagine you were creating an environment and you have a lot of trees in your environment. And your artist is pretty happy with those trees. But then one day Christmas rolls around and the art director says, hey, we need to add Christmas ornaments to all the trees. Now you're going to have a difficult problem. Your artist is going to have to go through every single one of these trees and add the additional Christmas ornament geometry. Right? Fortunately, Unity has a solution to this, and it's called prefabs. So essentially what you can do is you can take any game object and you can save it off as a template. Then you can place this templated object, what we call a prefab, all throughout your scene. And then when you need to make a change, you make that change in one location, and that change would be propagated out to all of the other, in this case, trees in your environment. So that definitely helps speed up the iteration time. You can have multiple different types of prefabs, and at runtime through script, you can also change individual properties on those prefabs. So you can change that at runtime. So I want to jump in and just describe how do you drive the editor. In order to do anything really in Unity, you need to understand the editor and you need to know how to get around it. So I'm hoping tonight I'm going to basically be jumping back and forth between the PowerPoint presentation and the Unity editor, because I want you to actually see in real time how you create this kind of content. So I guess since I'm going to be using the mouse and keyboard a lot, I'm probably not going to use the mic quite as much. I'll try to speak up, but if you can't hear me, just let me know. Well, I guess I can cover this now. So in the editor, we've got several different views, and this is what I'm about to point out. But we have our scene view, we have our game view, we have our hierarchy panel, and project panel, and inspector panel. Now, when I open up Unity, you're probably going to not see the exact same layout. So don't be confused by that. I'll explain that in a moment. But just kind of keep these words in your head for now. Okay, can everybody hear me?
I'll hold a mic for you just so the live stream can catch it.
Oh, yeah, sure, absolutely. Yeah. Thank you. Okay, can everybody hear? Okay. So before I was just saying that we have a scene view. So this is essentially where you're going to construct your scene and you're going to place your game objects. You can move around just using your WASD keys and your mouse. And you can select various game objects just by clicking on them. Below here, this is called our game view. And this is what the user or the player is actually going to see. One thing that's kind of interesting is when you click your camera, you'll actually see a little preview down here that shows also what the player's going to see. So if you want, you can change your layout in Unity. You can actually move your panels around like this. So you have more screen real estate for your scene view if you like. But for now, I'm just going to divide it up like this. Over here, we have our hierarchy panel. And your hierarchy panel is basically going to be a list of all of the game objects that are in your scene. Below, we have our project panel. The project panel is basically a mapping to your file system for your project. So these are just all the files that are included in that project. One thing that's kind of nice about this is you can actually create new folders and asset types and scripts directly from the project panel. The other nice thing is if you ever need to open up a particular folder with File Explorer, you can just right-click and do Show and Explore, and it'll just take you there directly. And one thing also I wanted to point out is that when you're creating assets in Unity, you're going to notice meta files. So for every asset in Unity, like a material, you're going to have a meta file. And this meta file basically just describes input settings. So let's say you have an image, let's say you have a PNG. The meta file will describe information as to whether or not that image should be compressed, or how many channels it should have, etc., or what kind of compression it should use. So every time you import or drag and drop an asset into your Unity project, one of these meta files are going to be generated behind the scenes. And we typically try to hide that from you because it's not something you necessarily need to interact with directly. And then finally, over to the right, we have our inspector panel. So you'll notice in the hierarchy, anytime I click a game object, my inspector panel changes. The inspector panel is where you're going to basically change your property values. So you can change things, for example, if I want to change what color my camera clears to, I can just change to solid color, and I can change my color here. And you're not going to see that reflected necessarily in the scene view, because it uses a different camera, but this is what you care about at the bottom of the game view. So what I want to do now is I want to demonstrate how you can create simple applications in Unity without writing any code. So what I'm going to do is I'm going to create a game object. This game object is basically going to be our floor. It's just a plane. I'm going to zero it out and put it at the origin. And while I'm at it, I'm also going to put our camera at the origin. Typically,
The screen's blank.
Okay. Perfect. Thank you. Okay. So I've just created a plane object for our floor. And then I'm going to select our camera. I'm going to set it at the origin. And I'm also going to change the clear color to a solid black. The reason I'm going to do this is that the HoloLens uses what's called an additive display. So essentially, black is going to basically be transparent for the user. Now what I'm going to do is I'm just probably going to move my scene out a little bit. I'm going to create a box. And since it's kind of the same color as the ground, it's perhaps a little difficult to see. I'm going to apply a different material to this particular box. And I want to scale it, so I can go over to the local scale X coordinate. I'm just going to stretch it out a little bit. Now I'm going to rotate it. Move it up a little bit. And that's about right. So now what I'm going to do is I'm going to create a sphere. Right about here. And I'm going to also assign it its own material as well. So we get this red. Right. Now what I'm going to do is I want this sphere to fall. I want gravity to be applied to it. If I just run the scene right now, it's kind of boring. It's not really doing anything. So what I'm going to do is I'm going to go over to the component menu. I'm going to go to physics. And I'm going to add a rigid body component. Now what I'm going to do is I'm going to duplicate this sphere because I want to have several of these guys falling. So that's just a Control-D, or you can just right-click and go to duplicate directly. I'm just going to position them in different locations. Now we're going to run this. Just like that, we have physics. So that's pretty cool. But I want to show you some other attributes in Unity, some other functionality we have. So let's imagine we have a box. Let's start with that guy. We're going to assign it a different color. Assign this guy to red. Now, let's imagine I want this guy to move, say, left and right. Maybe it's some kind of platform. There's several ways that we could do this. To start with, I'm going to go with the simplest approach, and we're just going to create an animation that moves this back and forth. So what we're going to do is, before you were seeing I was going up here to add component, you can also do it directly from the inspector over here. I'm just going to add what's called an animator component. And then I'm going to go up to Window, and we're going to go to Animation. And we're going to create a new animation. We'll just keep the default name for now. That's fine. And this is our timeline. So again, if you're familiar with Flash, it's the same kind of concept. We have a timeline here. As you change different properties on your object, you'll get different animations. So what we're going to do is we're just going to manipulate the X component of our object. So the very first frame, we want this to be -2. Pull it out for about 20 seconds. 26 rather. And then we just want it to loop, so we'll bring it back out. Set it back to -2. Now if you run, the box is animated. So that was pretty simple. But what if you want to do this exact same thing through code? Maybe you want to do it dynamically. Let's take a look at that. So we do the same thing. I'm going to create a box. I'm just going to give it a red color. Now we're going to write some code. So in order to actually move this thing with code, we need to create a component ourselves. So what we can do is we can just go down to, I like to organize my directory by asset type. So you don't have to follow this. You can do whatever you want. I'm going to create a new script in here. I'm just going to go to create. C#, and I'm just going to call it platform movie. And what I'm going to do is I'm going to drag and drop this onto our cube, so you can see it right here. But it doesn't really do anything yet. So if I just run, nothing's going to happen. So just by double-clicking the component, Unity knows to open up whatever your default IDE is. In my case, it's Visual Studio. You can actually change this in your preferences if you prefer a different studio or different IDE, I should say. I like my braces on the next line, so yeah, I'm one of those. Okay, so what we want to do is we basically want to move this thing left and right? So I just want to attack this from, I want to make this problem simple. So what I know is basically I need to know what my original position is, and then I just need to add some kind of offset to it. So what I'm going to start off with is I'm just going to go ahead and create a vector. I'm going to call it original position. Now I need to store my original position. Now before I do that, let's talk about what a mono behavior is. In Unity, any component that you have has to derive from a mono behavior. The mono behavior is going to give you certain things. It's going to give you access to your game object that that component actually lives on. And it's also going to give you the ability to access and query other components on that. So for example, in this case, I need to get access to my transform so that I can store my position. So I'm going to do that momentarily. The other thing that's interesting about mono behaviors is that the game engine inherently knows about these mono behaviors. So it knows to call certain functions like your start function and your update function. If you check out our documentation online, you'll see we have a slew of callback functions that we can use. In this case, we're going to keep it simple and just stick with the start and update that Unity has already provided for us. The start is essentially going to be our initialization function. It's only ever going to get called once when the object is created. And then our update function is going to get called every frame. So what we're going to do is we're just going to go ahead and store our original position once. So because it's a mono behavior, I can access the game object directly. And transforms are kind of special components, so they're sort of just built into the game object, so I can access it this way. And I'll just grab the position. We don't need to show that. All right. So now in our update, this is where our real magic is going to happen. So again, I need to move this thing left and right. So I know that I can do this with just using a sine wave. The sine wave is just basically going to oscillate, and I can choose what direction it goes. So what I'm going to do is I'm just going to take the float, I'm going to call it t. I'm going to use the sine, and I need some variable that's just always going to increment. I could create my own theta variable for the angle, but in this case, I'm just going to use time. And what I want to do is, the sine is going to give us something between -1 and 1. What I'd really like is I'd like this thing to be between 0 and 1. So what I'm going to do is just multiply by 5 and add 5 to it. So you can imagine if you multiply -1 by 0.5, you're going to get -0.5, and if you just add 0.5 to that, you get 0. And the opposite is true if you have 1. You basically multiply by 0.5, you get 0.5, and then you add 0.5 to that, that's going to bring you back to 1. So now we're working in this 0 to 1 space, which is actually going to be convenient for me. Next, I'm going to create another vector. I'm going to call this offset. And here what I'm going to do is I'm going to use a special static method on the vector3 class called lerp. Basically what lerp stands for is it's a linear interpolation. So you can think of this, again, if you're used to Flash, this is basically going to be the thing that's doing the keyframing. It's going to create the in-between positions between your start and your end point. Between. So I'm just going to arbitrarily choose a value. So I'll stick with what we had in the animation. We'll just start with -2. That'll be our start position. And we'll end at 2. And what we're going to do is we're going to plug in the t value that we calculated over here that's between 0 and 1. So what this means is when t is 0, our object is going to be at this location. And when it's 1, it's going to be at this location. And then finally, I need to take the original position and add the offset to it and then assign it back to this game object's transform. So we're going to do that like so. All right, so I think we're ready. So down here, I don't know if you saw the little pinwheel, but anytime you make changes to scripts, Unity will recompile them, and basically you can tell when it's done compiling when that little circle, the little pinwheel goes away. So voila, now it's moving back and forth. That's kind of cool. But why did I do this? I could have done the exact same thing in an animation. It seems silly to just create a script. Well, the nice thing about scripts is we can make them configurable. So what are some things that we can change on this? Well, one thing that would be nice is to allow designers to change the speed at which it moves back and forth. It would also be nice if designers could control the offsets. So how are we going to do that? What I'm going to do is I'm going to create a public variable. It's going to be a float. And I'm going to set its default to 1, so it's no different than what we currently have. And then I'm also going to create 2 offset positions. Just call these offsets. And then what I'm going to do is I'm going to take whatever our speed is, and I'm going to multiply that by our time, so we're changing the frequency at which we're moving back and forth. I'm going to take our offsets, and I'm going to replace our hard-coded values with whatever those offset values are. All right, let's go back into Unity. And if you pay attention over here, I now have 2 new properties that designers can manipulate. One is called speed, and the other is offset. So you'll notice that these 2 property fields are set to what the default values were in my script, which are up here. And I didn't set any default values for my offsets, but I did create an array that has two potential values, so Unity figures that out. You could add more if you wanted. And I'm going to go ahead and set this back to the values we've been working with for our offsets. We'll do play. That's kind of slow. I'd like it to go faster, so I'm going to increase that. So dynamically, I can change the speed at which it's moving, make it really fast. Hope I don't make anyone sick. And that's pretty cool, but I'd also like to change the location at which it's interpolated to. So I can do that dynamically as well. I would like it to move along the y-axis as well. And I can change it on its z-coordinate as well. We'll slow it down a little bit. So you can see that this is really powerful. This is really great for designers because they can rapidly fine-tune their experiences. And then when you're done, you can just write down those variables and you can just set up your component with them. And every time you run, you'll always start with those values. So the next thing that I want to show you is something that's a little bit more applicable to the HoloLens. One of my colleagues actually came up with a clever idea for a demo he was doing, and he called it the object finder. And today I've implemented it for you. Basically, the idea is, imagine in your experience you have some kind of hologram that you've placed. You've allowed the user to place it themselves. So you can imagine maybe it's a terrain map or something like that. And I don't know about you guys, but I'm often fairly clumsy and I forget a lot. So I may forget where I placed this hologram. And a lot of times, if you forget where your car keys are, you almost wish you had some kind of device that just guided you to your car keys. Well, in this demo, what we do is we actually guide the user to where that hologram is. And I'm going to show you how we implement that. So basically what you're going to see in this demo is I'm going to have 4 different spheres that I created. And what I want to do is I want to reduce this problem. Basically what I know is that the user can only see what's on their screen. So if there's a way that I can reduce this problem so that the x-axis is, say, -1 to 1, and the y-axis is -1 to 1 as well, that's going to reduce this problem a lot for me. And then what I can do is basically, if it's outside of those 2 fields, then I can just highlight the sphere to let them know what direction they need to look. So I'm going to show you this demo. I think I need to change my display version. All right, so we're in our scene view, and these are the 4 spheres that I was talking about earlier. And this is our object that we want to find. So just pretend this is something that you've placed somewhere in your environment. So if I move this here, we don't need to find it. It's clearly in our field of view. However, if I move it too far to the left, the red ball indicates, oh, you need to look or rotate your head to the left. Same thing is true if I move it too far to the right, you need to look to the right. It also works for cases where you move it up too high or down too low. And in the case that it's actually behind you, we tell you, oh, well, you just need to keep rotating to the right or to the left based on where it's at. So in this case, if I move it to the left, we can figure that out as well. And then we can dynamically rotate this guy. So it's in our field of view, we're good. Oh, we need to rotate back this way. Same is true if we rotate up and down. Great, so you get the idea. So how did we actually build this? So what I did was I have a main camera, and I just created, like you've been seeing me do, ordinary spheres. They're just game objects. And they're actually just the default game object. There's nothing special about them, except for the fact that I applied a different material to them. And this particular material allows me to set different colors on the object. So basically, I'm changing between white and red. And then what I did was I specifically made these game objects a child of my main camera. So why did I do that? The reason I did that is because what I want is when you're looking around on the HoloLens, I want these spheres to follow you. I always want them to be tracked with your head. So when you're developing on the HoloLens in Unity, the HoloLens transformation, its position and orientation, will always be forced on your main camera. The main camera will take on that transformation. So anything that you make a child of your main camera will be along for the ride. So in this particular case, that's very useful and convenient for me. The next thing I did was I created my own component called an object finder. And what I did was I have 5 different public references. And basically, these are just different slots. I needed to know what are the assets for up, down, left, right. I need to bind that to some variable. So in this case, designers, they can just drag and drop these references in place. And then lastly, I need to know what's the object that I need to find. If I wanted to, I could create another object. So just create a capsule. We'll move it over here. And I could easily just redirect this to point to. I could easily just redirect this to point to that particular object. So, and now, if I play, I can move this thing around. And it's in my field of view, and it now just totally ignores the cube over here. So that's pretty cool. So let's look at the code. All right, so this is business as usual, what you saw before. We just have some public variables. That allows us to expose those to our designers. And in this case, I need to know about the camera. You'll see in a moment. I need to get the projection matrix and whatnot from that. So in our start function, I do this to get a reference to our camera. Basically, in a mono behavior, you can do a this.get component. And it uses templates, so you can actually just pass in whatever the class name is that you're looking for. And in this case, I know ahead of time I'm going to have a camera on this. So I go ahead and I search for the camera object, and it returns the instance to me, and I just store it in this variable so that I can use it in my update. In the update, we're doing a little bit of math here. And I'll try to explain a little bit what we're doing here. So the first thing that we want to do is we need to know where this object we're trying to find is relative to our camera. So to make the math a little bit easier, what I want to do is I want to temporarily position our camera so that it's at the origin and so that its forward vector is looking along the positive forward axis. And that's going to simplify things because once I've done that, you can imagine if my camera is facing over here and my object's over here, by using the inverse transform, I'm orienting my camera so that it's facing along the origin, right? But again, this object defined is coming along for the ride. So now I can just check its x-axis and its y-axis relative to that camera's new orientation. And that's going to simplify this problem quite a bit. Now, the other thing I said before was, ideally, I want to figure out an axis that's between -1 and 1 for both the x-axis and the y-axis. I don't really want to care about like aspect ratio and all that stuff. I just want it to be between -1 and 1 so that I can easily do an if check to see if we're outside of that bounds. So what I'm going to do is I'm going to take my new object to find position that is currently relative to my camera, and I'm going to multiply it by the camera's projection matrix. And without getting into all the details, essentially what you need to know is when you multiply something that is relative, in a space that's relative to your camera by its projection matrix, and then you divide by W, that's going to give you that coordinate space. That's going to give you coordinate space between -1 and 1, which we sometimes call your normalized device coordinate space. So once we've done that, our normal device coordinate x and y is going to, again, be between that -1 and 1 space. So what I can do is down here, I can just check to see if it's outside of that bounds on my x-axis. And if it is, then I just query my material for that game object, and I change the color to red or to white by default. That's really all there is to it. I know there's a little bit of math here, and perhaps in future talks we can go into more detail on that if it doesn't make a lot of sense. But Unity does a pretty good job of actually simplifying a lot of these operations, which I'd love to get into more detail at a later time. All right. So obviously in Unity right now we support the HoloLens, and one of the things that's really important to our developers is the spatial mapping. I've been working very closely with supporting spatial mapping with Unity, and we've provided multiple ways to get the spatial map data from the HoloLens. In Unity, one way to do it is we have a low-level C# API that you can use. I would recommend this for engineers. However, it comes at a cost. The nice thing is the trade-off is you're going to get a lot of flexibility. You're going to get to control your surface management, lifetime management. You're going to get to do all that stuff on your own. But that's also the burden. You have to do all that stuff on your own. Another way to do this is we've just recently created what are called spatial mapping components. And I believe there's something very similar to this in the Holo Toolkit. Essentially, the idea is, well, let me go ahead and show you what the end result is first. So what you're looking at is spatial map data of our office, and you'll see different colors. This is a shader I wrote. Basically, it's supposed to be a visual indication about how far an object is away from you. And this is based on meters. So each color is assigned to meters. So I think like red is less than or equal to 2 meters, and then green is 3 or less, so blue is 4 or less, etc. So this just helps us instantly measure distances or get an idea for distances. The other thing that's happening here is we have a little ball and it's moving around the scene. And it's not very smooth. The reason for that is I'm only using one raycast. We'll talk about that in a moment. But if you wanted your objects to interact more smoothly and glide more smoothly along, you want to use multiple raycasts and just kind of average that out over time. You'll also notice that periodically the spatial map data is updating, it's changing. So we're letting the scripts know every time we get information about changes. So to achieve this effect, basically in Unity we have these two components. They're called the spatial mapping renderer and the spatial mapping collider. To get what you just saw, all you need to do is add these two components to your game object. In this particular demo, I added these two game objects to the main camera. That way the spatial map data will just follow my head wherever my head goes. And they're pretty easy to work with. You don't need to write any code here. Really, this is all you need to do is just add these two components to any game object. If you don't add it to a game object that's moving, then your spatial mapping data won't move along with it. So that means if I were to drop a component right over here and not move it, and if I walk outside of that area, I'm only going to see spatial map data for that area. It's not going to just follow me. So you need to decide ahead of time if you actually care whether or not that data comes along for the ride. If you know, for example, if you're creating like a terrain map or something like that, you might not care about moving that spatial map component along with you. You might just want to keep it in the location. But you have the option to choose how you want to do that. With the spatial mapping renderer, there are a lot of little knobs that you can adjust. One of the things is our custom render setting. So when you're working on the HoloLens, one of the things you're going to quickly find out is in that particular demo, I was visualizing the spatial map data. But a lot of times you don't really want to do that. A lot of times you don't want to see the spatial map data. What you really want is you want that spatial map data to include other holograms. So what you can do is by default, you can just set the render setting to occlusion, and then we automatically have a built-in material and shader. And what it will do is it will render that spatial map data with a black material. And again, like I said before, that basically translates to transparency on the HoloLens. But it will also block out any holograms that are behind it. So you can achieve occlusion with that. So if I had a hologram underneath this table, I wouldn't be able to see it because the spatial map data for this desk would be rendering. So it would be blocking the hologram that's underneath the table. If you do want to visualize the data, you know, a lot of times some video games, one particular fragments, they do a really good job of showing little blocks where your walls are. For that, you can switch the render setting to custom material. And if you do that, you can either use our built-in colored wireframe shader or material, or you can supply your own. And that's also true for occlusion. If there's some new technique that you want to use for occlusion, we don't want to stop you from doing that. You can apply your own material as well. But we want to get you up and running as quick as possible, so we've supplied some default ones for you. A couple of other interesting things here is you can specify the time between updates. So constantly the HoloLens is going to be scanning your environment. It's going to be collecting spatial map data. But every time we get the spatial map data in Unity, we're going to have to instantiate new surfaces to represent that. So you can kind of control how often that happens. You can also control the level of detail. So if you want a really nice high level of detail representation of your environment, you can just toggle that to high. I would recommend medium and high for visual surfaces if you want to visualize it. But for collision, for the collider down here, typically I suggest low, even though I use medium here. And then lastly, the bounding volume type is important. So right now we support axis aligned boxes, and we also support spheres. What your bounding volume is basically, imagine a bounding volume is sort of like a viewport if you're working with 2D or 3D graphics on your monitor. The bounding volume is basically going to be the area that the HoloLens reports spatial changes. So again, if I leave my object that contains my bounding volume over to my right, and I walk away, I'm only going to see updates for that area. If I want to have the effect that it seems like it's following me, I need to perhaps attach it to my camera and let it follow me around. All right, so we've talked a little bit about the spatial mapping, but you know, spatial mapping isn't really interesting unless you can interact with it. A lot of demos that I've seen, people will place objects or anchor objects. So you might have a virtual TV that you want to place on your wall, or you might want to place a picture or some kind of application there. But you need to somehow connect that hologram with your physical surface. One way to do that is through raycasting. So I've got a little demo here that I put together that I wanted to explain because you're going to use this a lot. Just move the screen here. Okay. So I've got a simple little scene here. And what's going to happen is when I hit play, this little ball is going to follow my mouse. So wherever I move it, essentially we're going to cast a ray from the camera, and we're going to see if we intersect with any geometry. And if we do, basically we're going to position the ball there, and we're going to move it out slightly off the normal, just so that it's slightly in front. But you can see here, it doesn't really matter what geometry I use. If I use the built-in game objects, or if I use a model from Maya, it works the same way. And this is important to you because when you're working with spatial mapping data, if you notice, when you look at one of these game objects, it's got this collider on it, right? We have different types of colliders. We have sphere colliders, box colliders, capsule colliders, and then the most expensive are mesh colliders. And again, what these are going to do is they're going to take the mesh data that's in the mesh filter, and they're going to create a volume from that. This is important because this is how the spatial mapping components work. Essentially what you're going to do is, at the end of the day, when the components generate these surfaces, they're automatically going to assign mesh gliders to these surfaces. So what you're going to be able to do is you're going to be able to raycast against them just like you would any other game object in Unity. And you're going to be able to either, like I did here, place another object off of it, like a painting or virtual TV or something like that, or other interesting applications. So let's look at how I did this. So again, there's nothing special about these game objects. They're just assets that I imported from Maya. And these are the ones that I built internally. These are just regular game objects. And what I did was I created this little game object sphere, and I attached this component raycaster to it. If you open this guy up, there's not a lot of code to this. Essentially what we're doing is we want to get a ray. And the way that we get this ray is we ask the camera to give us the screen point to it. So what this means is we're going to take our current mouse position, and you can substitute this with anything. You can substitute this with like whatever your look direction is if you're actually wearing HoloLens. But basically what we're going to do is we're going to take our mouse coordinate, and we want to figure out what the ray is. So we can start from the camera's position, and then we need to get a direction into our world. So this helper function calculates that ray for us, and a ray is just basically going to have your origin, starting location, in this case it's our camera's position, and then you're going to have the direction. And this is going to be in world space. And then this structure here, raycast info, this is going to store our result. It's going to store whether or not we actually hit anything. So next we're going to ask the question, did we hit anything? So to do that, we have the static method. It's a physics.raycast. You pass in your ray, and then it's going to output your raycast hit info. And here you can just specify the distance, how far along that ray should it check. There are a lot of different flavors of this raycast function, so I would invite you to explore it. You're going to see some things like layers and stuff like that. Just briefly, when you're in Unity, you can assign objects to different layers. So if you look up here in the inspector, you can add a layer and you can create one of your own layers here. You can give it a name. So what the layers allow you to do is, if you have a really big scene with a lot of geometry in it, and all you care about is, am I intersecting against this one sphere in my scene? You probably don't want to do that kind of math with all of those triangles in your scene. You really only want to focus and target your raycast against that one sphere. So by assigning that sphere to a specific layer and then passing in which layer you care about into your physics raycast, that's going to reduce the complexity of that calculation. In my case, I don't really care too much. This is a simple scene. So these are just kind of your basic bare bones parameters. From here, what I want to do is I want to actually offset the sphere so that it's not clipping with the object that it's colliding with. So since I know ahead of time that this is a sphere, I just need to get the radius, and I can get that by getting whatever the x, y, or z coordinate is of the scale. And then I'm going to take whatever the hit position was, wherever the intersection point was, and I'm going to add the normal at which I hit it, multiplied by the radius of my object, and that's going to be my new position. And then here it's just business as usual. I assign that new position to my transforms position, and voila, my sphere is now going to be positioned off of my object state. Now, you're not always going to have to do this yourself. Dimitri alluded to this earlier. I know the Holo Toolkit actually has a data manager, and it does a lot of this work for you. But behind the scenes, deep down, this is basically what it's doing. So I just want you to be aware that you can actually do this yourself too if you need to create some interesting experience. All right. So I know some of you have heard about shaders. This is also something that's really interesting. This is something that I'm actually very passionate about. I really enjoy writing shaders. They're a lot of fun, and we'll get into that a little bit. Unfortunately, though, shaders is kind of a really big topic, and we just don't have time tonight to go into the deep details of how you write them. But I want to give you a quick overview because they're really quite amazing. So shaders is kind of a bad name. Really what shaders are, they're basically just programs that run on your GPU. And we write these programs in a specialized language. There's a language called CG. It was originally developed by NVIDIA. And then there's a language that's very similar. It's Microsoft's version. There are some subtle differences, but it's very similar. It's called HLSL, High Level Shading Language. And then OpenGL has its own flavor, GLSL. Most of the time in Unity, we write our shaders in CG, but you can also write them in GLSL as well. And we can use the shaders for a lot of different things. Historically, typically they're used for lighting. So if you had a particular way you wanted to light an object or surface, you can do that. Something that I'm more interested in is visual effects. And then you can also use them for computation. GPUs are basically set up so that they can run calculations in parallel really, really well. So you can get some really interesting calculations very quickly, and then you can send that back to the CPU if you'd like, or just render it directly. So this is essentially the rendering pipeline. We're not going to go into all of these steps, but I'm going to draw your attention to the vertex shader stage, the geometry shader stage, and the pixel shader stage. So with the vertex shader, essentially what's going to happen is you get this simple main function, right? And the input is going to be your object space coordinates. So if your artist created, say, a sphere in Maya, the values that are going to be coming into this vertex shader are the coordinates that were created by the artist in Maya. And the output for this function needs to be those coordinates in what we call clip space. So typically what happens is we have a matrix that we call your MVP matrix, which is just your model view projection matrix. And essentially all that matrix is going to do is get it into the right space. It's going to get it into clip space. From there, we have a geometry shader stage. So we use this for our shaders for spatial mapping. Essentially what a geometry shader is when you create these vertices, if you want, you can dynamically create additional vertices. So if let's say for example, I had passed points into my shader, right? Just raw points, raw vertices. For each one of those points in the geometry shader, I could blow those up into quads, into squares. I could just add 4 additional verts, and I could make that original vert the center of my quad. And this is really cool. You can do some interesting things with this. I was before playing around with, instead of having like triangles for the spatial mapping, having blocks that are kind of highlighted with different colors. It was just kind of an interesting visualization. So that's pretty cool. And then lastly, you have your pixel shader stage. The pixel shader stage is probably the most interesting to me. That's basically the final say in what gets rendered to the device or to the monitor. And you can do some really cool things there. We'll get into that at a later point. But basically what you need to know is the input is going to be whatever is output from your geometry shader or your vertex shader. And the output is going to be a color typically. It's just going to be what's the final pixel color. So what I want to do is I just want to modify the scene. I want to create a new material and a new shader, and I'm just going to keep it simple. All I want to do is I want to have my cursor fade in and fade out over time with a different color. So what I'm going to do is I'm going to come in here. Oh, yeah, great. Thank you. Right, so what we're going to do is we're just going to create a new material. Thank you. So we're just going to create a new material, and we'll just call this color fader. And by default, it's assigned to the standard shader. You can go in here and you can select other shaders. So the way I like to think about a material is if a shader is a GPU program, a material is more or less the command line arguments you pass into the shader. So the material is, typically your artist is not going to be interfacing directly with the shader. They're going to be interfacing through material. And from the shader, you're going to provide properties in a very similar way that you would in script that your artist or designer can manipulate and change. And I'll show you that in a moment here. So now that I've got a material, I'll just go ahead and assign that to my cursor. And the only thing that's left is now I need to create a shader. So I'll go down to my shaders. I'm going to create a new shader. And I'm going to create an unlit shader. An unlit, you'll see several different types of shaders here. The unlit shader is basically the lowest level shader. Perhaps for another talk we'll get into surface shaders and whatnot, but for now, unlit shader, that's basically your low level pixel shader, or vertex shader. Create one of those, and we'll call this color faded. And you can just open this up in Visual Studio. And Unity is going to go ahead and generate some default code for us. All right, so what do we have here? So whatever the name is here, and you can change this to whatever you want, you're going to find it in the exact same space over here. So that was called unlit color fader, so it's going to be underneath this unlit color fader selection here. I'm going to select that. And then under properties, this is where you have a chance to expose certain variables to your artist. For this particular demonstration, I'm not going to use a texture. I'm just going to use two colors. So I'm just going to do a color 0. We'll just call this color 0. So what I'm putting in the string here, this is what the artist is actually going to see in the panel, in the inspector panel. And this is going to be a color. And I'm going to set some default values. So I'll set this initial one to white. So just and we're going to have another color that we're going to fade to. And we'll call this color 1. And I'm going to make it move between red and blue. So I'm going to adjust these values so that it matches red and blue. And I'm going to go back to our editor and just make sure that we see that. So now we have these two color values. And we have the red and the blue. So go back to code. And inside of the subshader, this is where I'm actually going to write my code to do something interesting with this. So the first thing you're going to notice is that Unity automatically tries to do fog for you. For this particular demo, I don't need fog, so I'm going to get rid of it because I don't want to do any more calculations than I absolutely need to do. I'm going to get rid of these variables because I don't need this here. And we don't need fog, we don't need UVs, so we're going to get rid of that stuff too. And in our pixel shader, we don't need that. All right, great. So what we're going to do now is we're going to create a new color. And by the way, this is our pixel shader. The way, there's nothing special to the names of our vertex shader and our pixel shader. The way that Unity knows which is which is up when you define your program. You have to use this pragma and you set vertex and fragment, and then this is the name of the function you want to use for those. So that's how that works. So what I'm going to do is very similarly to the vector.lerp, there's a built-in lerp in CG, so we're going to use that. And I'm going to define these values inside of my pixel shader. And we have color 1. And then the only thing that's missing is, again, just like in the previous demo, we need some kind of t value. We need some value between 0 and 1 so that we can interpolate this. So we're basically going to more or less do the exact same thing we did earlier. We create a float t, and we're going to do a Sign. And then Unity will pass in the current time, how much time has transpired since you started your application until now. And we're going to use the Y component of that. So I know this is a little bizarre, but basically your time variable is going to be a 4-dimensional vector. And in each slot, there's a different version of the time. You can get time, I believe it's like time divided by 8, what the actual time is, time divided by 2, etc. You would have to look at the documentation, but the current time is actually stored in the Y component. Now this might seem strange, but the reason this is the way it is a lot of times Unity will try to do as much work up front as it can on the CPU, especially if it's something that only needs to be calculated once. And that way you don't have to keep doing that calculation per pixel or per vertex. And we'll just multiply this by 2 for now. And again, the same thing, we want it to be between 0 and 1. Put this t value in here. Get rid of this. And hopefully I did not mistype anything. All right, that's a good start. Now if I run, you see the color change. And of course, I can add more properties. So just like before, if I want, I can actually add speed here as well. So just do speed. And here we can either say this is going to be a float, or we can say range. So if we don't want the artist to go outside of a particular boundary, we can say what the limits should be. So in this case, I can say 1 to 5, and I'll just default it at 1. Now, something that it's very easy to get tripped up on is when you define your property here, you also need to define it down here. Otherwise, bad things happen. You won't get the effect that you're looking for. So, and then instead of multiplying by 2, multiply by the speed value. And now you see this slider here that we can adjust. So now if I run, I can change the frequency. The last thing I want to show you here that's really cool about shaders is that you can adjust them in real time. So if I come back in here and let's say I just want to make it red all the time. Just change this to that hard-coded value. And I can go back to Unity and go. So if you make a mistake, Unity will, if Unity can't compile your shader, it'll set it to a magenta color. And then down here in your console, you'll get an error. So go back, see what I did wrong. Oh, I didn't see fix 4. There we go. So now if I come back in here, it's red. So that's kind of a quick demonstration of shaders. They're a lot more interesting. I know this is kind of a boring example, but there's a lot of really amazing things you can do with them. And shaders are really quite important for building cool holographic experiences. All right, guys, so that really concludes my presentation. I just want to remind you guys that we really care about making Unity work well for you. So if you guys have questions, if there's anything that we can do to help, I can tell you personally, I'm checking the forums like at least several times a week, and where I can, if I can write examples to, if you have questions and you need an example how to do something, let me know. I'll be on the forums, and as soon as I have time, I'll create examples. But yeah, we're here to help. We want to set you guys up for success. So please check us out on the forums. We do care. And with that, are there any questions?
Which Unity lighting controls are available for use with holograms?
The lighting controls?
Yes, yeah, what would you suggest?
As far as what?
Being able to make scenes and objects and scenes. And
Oh, so you mean like directional lights and point lights and stuff like that?
sure, all of that, yeah.
So typically with Unity, with the HoloLens, you're going to want to minimize any kind of complicated rendering. It's more or less, you want to develop with the mindset that you're developing for a mobile platform. So what that means is you're going to want to reduce your usage of the standard shaders, so like the physically based rendering and stuff like that. you might not want to take advantage of that at the moment. Instead, you're going to write a lot more of your lower level shaders, kind of like what I was showing there. And you can use things like your directional light, your point lights. Those are all fine. They should be fine. And then you're also going to want to take advantage, I guess, if possible, if you need to do light mapping or light baking, right? Then you can go ahead and do that as well. I guess it's going to be a little difficult though, especially when you have a dynamic environment. So it's kind of hard to answer that. So we're still learning ourselves. We're still learning what the best workflows are.
You mentioned you're really passionate about shaders. Can you give an example of a really complicated, crazy shader that you haven't worked?
Let's see.
Example of a complicated, crazy shader.
Well, let me see if I have. I don't know if I have internet connection. Do you know how to connect to the internet? Is it the top? Oh, perfect. Let me jump over to my website and let's see. I can show you something there. So this is one that I had a lot of fun with. It's an energy field. Oh, sorry. Keep forgetting about that. So this is an energy field. This is actually procedural, and it's being calculated for every single pixel. This is not something, though, that you would typically do in game development. I'm actually, this is kind of just for fun, but we're actually calculating the formula for every single pixel. So there's actually no asset for this. It's all just using math. We also have a few others. This is a technique called ray marching. Again, this is procedural. There's no asset. It's all just being calculated on the fly, but it's a blob. And essentially what we're doing is, there's actually only two triangles here, believe it or not. It's your screen. We have one triangle from the top left and one at the bottom right. And for every single pixel in that quad, we're computing what the color of the pixel should be. And we're doing a technique called ray marching. And ray marching is very similar if you're familiar with ray tracing. And then we're just adding like a noise field to the sphere to kind of give it that liquid dynamic shape. So this is why I said, like, I really like shaders. You can do some really cool things with them, but they do come at a price. So. Any other questions?
Yeah, so talking about the occlusion, right, on the spatial mapping, when you do like a mixed reality capture system, being black, where you like watch out all of the real world. Have you guys looked into, like, are there any techniques to occlude, but also not do it in a way where you're not rendering black pixels, or you know what I mean?
Yeah, that's a good question. Yeah, that's a good question. So not yet. All I can say at the moment, because again, we're still trying to figure this stuff out ourselves. What I can say though is if you do have any interesting ideas, the spatial mapping component, you can supply your own material and shader, and we'll use that. We'll apply that material to all the surfaces, but not as a real. That's an interesting idea. Anything else?
So with Unity F3 out now, are we going to see HoloLens kind of merge into that, or is this going to be a separate release that we're going to run?
Yeah, so the plan is that we're going to very soon migrate directly to Trunk. So basically, you're going to get the same build that you would download for Unity typically. That's going to be the build that you use. You're not going to have to continue using technical mesh. Have you guys, by the way, has anyone tried out the new Universal installer? Because before you had to download separate installers. Now it's just a unified installer. So hopefully that will help things. Anything else?
I have a quick question about HoloLens in particular, and this functionality that meets reality capture. And sometimes when you run the sprites in your game that have a transparent component, the way it comes out in the mixed reality capture is actually black.
Right.
Yeah. And so I was wondering if you could, maybe some trick on the shader side that we could apply to get around that.
Yes. So actually, I'm glad you brought that up. Let's surf over to the Unity forums, because I actually posted an example about this. Oh, guys, if you haven't seen this, the Atom demo, you should check it out. It's pretty interesting, interesting kind of creepy story. Okay, so let's go over to forums, and if you go down to HoloLens, I believe we have a thread, some cool examples of shaders that you can create for the HoloLens. This is something that I put together, and I'd be happy to go into the code with you guys at a later point, but I just thought it would be interesting to, since I have this passion for procedural shaders, I wanted to create a procedural shader for the HoloLens, but I also wanted it to analyze music and do some kind of beat matching with it. It's just for fun, So it's funny you bring that up, Dimitri, because one of my coworkers, he was recording this experience. And when he recorded it, we quickly saw the little black squares around all of these little particles. And the problem was that the alpha for that object was set to 1. If you're recording with mixed reality capture, you want to change that to 0. And then you'll get results like this. Any other questions?
I'm curious about your development workflow. In Unity, do you use the emulator? Can you imagine, do you need to see it on the HoloLens to know what it's going to look like?
Yeah, so developers are very different about this. For me personally, I rarely use the emulator. I almost always test on the device, and I think that's just because I kind of come from the game industry, and we're hardwired to never trust the emulator and always work directly on the device. And so to answer your question, I'm not saying that the emulator doesn't work. I'm just saying that that's just my workflow. That I always like to test on the device because at the end of the day, that's what matters the most. It does take time to deploy. That's why I try to do as much as I can in the editor. And once I have enough faith that it will work in the editor, or it will work on the device because it works in the editor, that's when I transfer over to device and start testing it there. And the other thing I do is, this is kind of interesting. It might help your workflow, but if you're testing on device, if you've created, you'll actually, in your Visual Studio project, you'll see your C# scripts. So you can actually change things inside of your C# scripts, and you can redeploy. And you can keep doing that without having to go back to the editor and rebuild it and stuff like that. Another thing that I do is I have like my own, for our own internal tests, I have like a voice controller. So I have a bunch of preset commands, and I'll just use those commands and I'll test different things that way as well. But yeah, that's something that we're working really hard on though. We're working really hard on improving that workflow so that you can iterate very quick, just like you would anywhere else in Unity or any other platform.
So one other thing that I've noticed when I'm working on in Unity with HoloLens is that since you're room scale, all your objects are like in feet or inches. You're not massive. And when you zoom in the editor, that size, it's really tricky to be precise. Zooming and just navigating and seeing. Is there any way to like adjust, to like, compensate for that scale in terms of how you're working in the editor?
Yeah, so there is a way you can do that. It's a great question. So when you're importing assets, in fact, I had to kind of more or less do that for this scene. I just grabbed this model of this guy online, and what you can do is inside of your project panel, for any asset you have there, let me see if I can find one real fast. It should be on the models, mail 02. There we go. So in your project panel, if you select your asset, you're going to see the import settings over here. You know, earlier I was talking about the meta files. Essentially, all the changes you make here will actually get serialized into the meta file. So up at the very top, you have a scale factor. So you can adjust the scale factor and you can hit apply, and that will propagate that change to all the other objects. So it kind of depends on what units you're working with, like in your Maya or Max and whatnot. But you can adjust that scale factor here, and you can figure out what works best for you.
Just to hinge off of that question, what is the relationship between Unity units and the HoloLens units. I created 3 views, for example, 5 units apart. I put them on the device, and they are definitely not meters.
Interesting. So it should be meters. If that's not what you're seeing, you should file a bill.
Okay.
Any other questions? All right.
One more, sorry. So how long until the Unity flavor or the HoloLens flavor of Unity merges back into name? Can you say?
Yeah, that's something I can't quite say. I will say that we're working very hard on it, and it's at the top of our radar. So yeah, I don't want to give any exact dates yet.
Thanks again for that, Brandon. Anyone who wants to follow Brandon on Twitter, if anyone here is on Twitter, your handle is
B. Fogerty.
B. Fogerty. Yeah. And I've tweeted out a couple things already tonight from there, so yeah, you can find that handle on my Twitter stream. All right.
Sounds great.
Yeah.
You guys get great. Thanks. So, a couple notes. Also on the WinHUGR website, for anybody that's registered as a member, it's important to check out our member discount page. Currently, Manning Publications has a significant discount off of all their stuff, one of our sponsors. Pearson is a recent sponsor that we've added on, but we've had some communication problems of not hearing back from them, so they're currently in a status unknown. But hopefully they'll be updated soon and have their user group discounts available to us there as well. Speaking of sponsors, a big thank you to all of our sponsors. Unity not only provided our speaker tonight, they also cover the costs of our meetup page on an annual basis and back us up to providing some cool swag for a few lucky winners tonight. Microsoft HoloLens Group is also a great supporter of our group, and we really appreciate it. Orange Studios, the space that you're sitting in right now, is a cooperative workspace, and there are a number of free passes up at the front door. So if you want to find out more about the workspace available here, please pick up a pass and find out more about them. They're a very interesting opportunity for folks with small businesses or looking for a place to hold meetings and other types of events. Group 3 has provided us some awesome pizza tonight, so we appreciate their support. Trimble, Leap Motion, and Wiley and Manning have also provided us some great door prizes. Speaking of door prizes, let's jump into that now. Hopefully you all got a ticket